C, when you have the x plus 8 squared, remember that you do have to FOIL that out. So you have x plus 8 times x plus 8 plus 3. So to simplify that, sorry, I'll zoom in. You do have to FOIL. Okay, so this would be x squared plus 8x plus 8x, so 16x plus 64 plus 3. So when you're doing the quadratic formula, it's x squared plus 16x plus 67. Okay, this is your h of x here. Okay, so now we can do the opposite of b over 2a, or sorry, that's your vertex. Okay, so we can do x equals the opposite of b, so negative 16 plus or minus the square root of b squared. 16 squared is 256, right? Okay, so 256 minus 4. My a is 1. My c is 67. Divided by 2 times 1. Okay, so 4 times 67 is going to give me 268. So this is negative 16 plus or minus 256 minus 268 over 2. And then I get negative 12. So when you have a negative, remember, you are going to put in what variable? I. So negative 16 plus or minus the I. And then what's the perfect square in 12? What's the perfect square in 12? 4. So this would be 4 and 3 over 2. I'm going to come down here. So negative 16 plus or minus 2I root 3. And then you're dividing both of these by 2. Okay, so negative 16 over 2 is negative 8. 2 and 2 are going to cancel out, so this is plus or minus I root 3. Okay, how did part A and part B go? With the simplifying.
So does the I have to be like behind the derivative 5 over 2 or for A?
Nope, did you write I root 5 over 2?
Yeah.
Yes, that would be perfectly fine. Yep, you could write I root 5 over 2, and that would be fine as well. That one you did have to do multiple reductions. So you should have the opposite of 2 is positive 2, and then b squared would be 4 minus 4ac divided by 2a. Don't forget to multiply by the 2a, because a lot of times that's a 1, but it doesn't always happen like that, so just be careful. And then 4 times 2 is 8, 8 times 3 is 24. So this is really similar to the one that we just did for our warm-up. Okay, so then this is going to simplify to 2 plus or minus I root 20 divided by 4. And then what's the perfect square in 20? 4. Okay, so then this becomes 2I root 5. And then you're dividing both of these by 4. Okay, and even if just one of them simplifies, you got to simplify that one. 2 over 4 is 1/2. And then this is 1/2 as well. When you simplify, and this becomes 1 and this becomes 2, you can keep that as I root 5 over 2. That would be perfectly fine. So you can write your answer like this, or you can put your I on the side. Either one would be correct. Okay, and then if you get a whole number answer, remember that's when you have to reduce. So Okay, so you have x equals the opposite of 8 plus or minus the square root of 64 minus 4ac over 2a. So 12 times 5 is 60. So 8 plus or minus the square root of 4 over 6. 8 plus or minus 2 over 6. So you have to actually do this. Okay, 8 plus 2 divided by 6. 8 minus 2 divided by 6. So 10 over 6 reduces to 5/3. And then 6 over 6 reduces to 1. All right, what questions do you guys have for me on the quadratic formula, the simplifying? Yeah. Yep. Yep. All right, so something else you guys might want to write on your note card is what the discriminant is. So I can't tell you what the discriminant is during the test, so you have to know the discriminant is just that b squared minus 4ac. Okay, so that's what you're going to have to do, and then when you're finding the discriminant, make sure everything is on one side of the equal sign. So you have 4x squared minus 28x plus 49 equals 0. Then you can do your b squared minus 4ac. Okay, so negative 28 squared minus 4 times 49. Okay, and that's going to give you 784 minus 784. That's why your discriminant is 0. So that is the number. And then there's one real solution if the discriminant is 0. Okay, for b, when you do b squared, you get 25 minus 4ac. Okay, so 25 minus 32 is how you get negative 7. And then you have to write two distinct imaginary solutions. If you think you're going to forget, like, what goes with which, okay, then maybe you want to write down, like, the distinct imaginary, the two distinct real. And then again, make sure that when you move it over, that you're subtracting, and then your b squared is 16 minus 4 ac. Because if you have a negative times a negative, that's going to turn into what? Positive. So this is 16 plus 84. That's how you get your 100. Okay, and then I said to use your notes because these were in your notes. So if it's positive, there's two distinct real solutions. If it's negative, there's two distinct imaginary solutions. And then if it's 0, there's one real solution. Okay, so you have to make sure you have the distinct and the real, the two distinct imaginary. Okay, questions for me on page 1? All right, let's look at the back part. Okay, so the simplifying. When you are simplifying, you have to write this in terms of the I squared. Okay, so these I'm actually going to do out with you. The whole reason why you're trying to write them in terms of I squared is because what do we know I squared is equal to? Yeah, so I squared equals negative 1. So if you're trying to rewrite this, all you have to do is divide this by 2. What's 72 divided by 2? 36. So 2 times 36 is 72. So I have represented all 72 i's here. So I just have to do negative 1 to the 36th power. Anytime you do a negative to an even power, you end up with a positive number. So 4a is just 1. All right, for b, we're going to do the same thing. I'm going to keep the negative 3 on the outside, but I need to rewrite this as I squared. It's an odd value, though. If it's an odd value, I'm just going to get to 1 less. So So to get to 16, right, if I divide 16 by 2, I get 8. So 2 times 8 is 16. I just have to multiply by one more I to get to 17. So if it's odd, you're always going to have an I multiplied on. Okay, and then plug in your negative 1. So negative 1 to the 8th power. Is that positive 1 or negative 1? Positive. So negative 3 times 1 times I is going to be negative 3I. Okay, and then same thing for the last one. Keep the 5 in front. We're going to rewrite this in terms of I squared. It's an odd, so go 1 less, 34. 34 divided by 2 is 17. So 2 times 17 is going to represent 34 of those i's. So I'm just going to multiply by one more. So I have 35. So I'm just rewriting this expression so that I can plug in negative 1 for I squared. Now I have a negative to an odd power, which means it's going to be a negative. So my final answer is going to be negative 5i. Okay, for 11a, I know the fraction kind of trips some of us up, but guys, all you're doing is adding. When it comes to adding fractions, this is pretty nice. 3 elevenths minus 4 elevenths is what? Negative 1 over 11, right? And then you have 3i, negative 3i plus I. Negative 3i plus I is negative 2i. Okay, so then your final answer is negative 1 over 11 minus 2i. You're just combining your like terms. Okay? So if you have a negative, this is where you distribute. This is plus 5 minus 3i. Then you just combine your like terms. Negative 5 and 5 cancel out. Oops, 3i and negative 3i, those cancel out, so you're just left with 0 for that one. Okay, so they both canceled out. Okay, for this one we're distributing. So 4 times 6 is 24, so this is 24i. 4 times negative 5 is negative 20, so this is negative 20i squared. Plug in the negative 1, and you have 24i plus 20. Now when you write your final answer, they all have to be in the form a plus bi. So it has to be written like this. Okay? They are all in this form, a plus bi. Okay? And then for ones like D, you're going to have to FOIL. So when you FOIL, you have negative 18. I like to do the middle. So plus 12i. 9 times 3 is plus 27i, and then negative 6 times 3 is negative 18i squared, which I know I'm going to plug in my negative 1 for that. And then sometimes I'll just make this my plus 18, combine my like terms, those are going to cancel. 12 and 27 makes 39i. Okay, I already wrote out my work for this one, so it is the same as D where you FOIL. 3 times 3 is 9. In the middle I have 6i. On the outside I have negative 6i. And then 2i times negative 2i is negative 4i squared. So these are going to cancel. I plug in negative 1, which is going to give me a positive 4. So for E, you should have 13. Okay, for F, this is just like what we did for our bell work today. Did you guys multiply by negative 4i over itself? Okay. So again, we're going to distribute on the top, because this is just one term. So you have negative 8i plus 20i squared, and then on the bottom, negative 16i squared. When you plug in the negative 1 for each of these, you'll get a positive 16 here. And this is negative 20. If you want to rearrange these to put them in the correct order, you can. And then you have to reduce each one. Okay, so what goes into 20 and 16? 4. So if you divide by 4, you have negative 5 over 4. And then this is minus, this is 1/2, so 1/2 I, just like that. Okay, for G, you're going to multiply by the conjugate. So the conjugate is going to have the same first value. The minus turns to a plus, and then you have 3i. Whatever you multiply by, it has to be the same on the top and the bottom, because then you're multiplying by 1. If you try to multiply by the conjugate of each one, that's not right. Okay, then you're completely changing the value. Okay, so for ones like this, you have to FOIL on the top and FOIL on the bottom. I like to do the bottom first, because if I did it right, these should cancel, right? This is positive 6i, this is negative 6i, and then negative times a positive is going to be negative 9i squared. I like to plug in my negative 1 right away, so I know it's 4 plus 9, which is going to be 13. And then on the top, 1 times negative 2 is negative 2. I like to do the inside next, which gives me 16i. 1 times 3i is 3i. And then a negative times a positive will be negative 24i squared. How are we doing at the FOIL? Okay, so first, outer, inner, last, or I like to do FEOL. And then you can combine your like terms. Just remember, if this is a negative times a negative, this is going to be plus. Okay, so this is a positive 24. 24 minus 2 is 22. 16i plus 3i is 19i. And then you just have to separate it. So a lot of times you are going to have simplifying to do, but there's not anything that goes in about 22 and 13 or 19 and 13. Okay, so we're going to leave it in that form. Okay? Okay, and then H is the same, so I'm just going to show you my work for that. So you're going to multiply by the conjugate. The conjugate is 9 minus 7i. So you have 81 minus 49i squared. Plug in your negative 1. So this becomes...
Miss Whipple?
Yeah. Oh, yes. Okay, sounds great. Okay, thanks, bye. Okay, and then you should get 130 on the bottom, and then on the top, I combined my like terms, so negative 63i and negative 63i was negative 126i. 81 minus 49, because 49 times negative 1 would be a negative, and then I simplify. So 32 over 130, 126 over 130. When I'm looking at those, I notice they're both evens, so if they're both even numbers, divide by 2. And then find the absolute value. We already talked about that today, okay? So that's where you do the square root of a squared plus b squared. Okay, so square root of 34, square root of 7. 3 squared plus 5 squared. Okay, and then this would be 0 squared plus negative 7 squared. Alright, and then let's look at our last worksheet.